Hello, my name is Eduardo Rios, and this is Lab 3. Today presenting for is Lab 3. It goes, the first part is the 4-bit incrementer. Um, so if you enable it, it will, how do you say it? It will increase and count every single time there's a positive clock edge, which goes from 0 to 1. And obviously, if you press the reset, it all goes to 0. And then, let me see. We'll do the GTK at the end. There we go. Okay, so I'll show the other ones now. They'll go to the GTK at the waveforms at the end. So you got RAM right here. Same thing technically. The adder you can increase it to 4 or whatever. Positive clock edge is there. You write it in. In there's like a sheet that it goes through. And if you go with the positive clock edge, it'll go in 1. And if you go in with the right, it'll change it. That makes sense. I don't know how else to explain it. Data in is 3, 2. It just changes by itself. Oh, sorry. The address, sorry. From the 0 up here, goes down. So as you can see, if I go up, it goes up to 5 and then 2, and the other ones don't have spaces. However, if you change in the data in and you write it in, clock edge, it changes. Sorry, I messed up the inputs for a second. Next one is gonna be, let me look at my notes, brainless, which is the big one, obviously. Here we have from lab 2, we added the invert, arithmetic, and pass, but we also added new elements or inputs, load, uh, to accumulator, accumulator to data bus, reset, clock, write, and read. So everything, so it kind of applies as the same. The address bus is still there, and if I read it, you can see here the data bus is 3, so it's reading that. And if instead I were to write it, the data bus is going to be 5, as you can see right there. Other noticeable things is that everything here connects. If you pass it through here, the LU out goes to 5. Um, you can go load to accumulator, but that doesn't go until you get a positive clock edge, and it goes into accumulator. And then obviously you can send that through. And I did test that. Let me show you the GTK waves now. Now that that's gotten out of the way. No. Share, just stop. There we go. Let me get out of here. Go here. Terminal folder. So let's go ahead and open the VCD for 4-bit rigs. And where is it? VCD. Yes, it could be this one. Was it this one? Oh yeah, 4-bit. Shred it. Clock, enable, QT. I don't think I'd reset, of course, if it comes up. But as you can see, it increments. Wait, did I pick the right one? Enable is up. Did I put the right one? Pretty sure I did. Let me try that again. I don't have enough time. Made this super late. Bring this GT. DIG. March 25th at 2:23. Sounds about right. 4-bit up. Yeah, it is 4-bit. Let me see. Didn't look right. Enable. You temp. Oh, I didn't mean to do that. resets. But yeah, you can see it increments. Let me push this over here. 059F A7 clock edges, increments, changes, whatever you want. But I did have to, um, how do you say it? I changed the stem file so it would have new inputs. I changed it to 5, 4, 9, and all that. That way you could see different things. And then when enable came up, it would change. So that's where the confusion came in. I just remembered that. But aside from that, let me show the other ones. The brainless one, the main one. So I was only able to get one of them up and running, and that was only because I didn't have enough time. So points off there. But the data in this is for the ALU, which I did an and a sub. And here you can see inverter arithmetic, sorry, inverter and pass are up, so I didn't use arithmetic like the other one. There's only one load to account to accumulator, and then there's no accumulator to data bus because I need to put in the data bus. I read it, I went from the file all the way and just pushed it through. I didn't write any inputs in. As you can see, the data bus reads in three, keeps three, and then the alley out reads C and C because the three gets inverted, and that's the new input. It gets ANDed first, which is 0, and then obviously inverted, which is basically subbed in for a new number. But yeah, thank you for your time.